All right, next up on ways to factor. I think we're up to number 4, aren't we? Oh, I didn't. I was just labeling in class, so I wasn't labeling on the video yesterday. Here's the 4th way. Uh-oh. It's not right. There it goes. Oh, it's behind. Okay. There's something called a perfect square trinomial. Okay. Now, the way to factor it is, it's another one. It's like difference two squares. You just have to. Why is this pen acting crazy? Hang on. All right, this is not good. You just need to recognize these. Okay. So what a perfect square trinomial is when you take a binomial, say 3x minus 4, and you square the whole thing. So you're doing 3x minus 4 times another 3x minus 4. So you get 9x squared minus 12x minus 12x plus 16. Okay. So just look at this compared to where it started, which actually I guess it'd be a little bit more helpful to compare it to what it looked like right there. You've squared the front thing, you've squared the back, and the middle is because you did this times this 2 times and put them together. Okay, so to recognize a perfect square trinomial, here's what you're looking for. Are the front and back perfect squares? If they are, then can you make the middle when it would have been times out? Okay, so like right here. Perfect square, perfect square. If this is a perfect square trinomial, which it doesn't have to be, but it'll be a 2x and a 1. And then the way to know it actually is 2x times 1, 2x times 1. 2x and 2x put together makes 4x. The way it would make negative 4x is if they'd been a negative 2x each time. So that's just recognizing that that's a 2x minus 1 all squared. So same deal. Let's see if it is. This and this, perfect squares. Oh, and this one's always got to be a positive because when you square either the negative or the positive, it'll turn positive. So if it's going to work, it's going to be a 10x on the front because that's what you square to get 100x squared. A 9 on the back. Here's 90x and another 90x, which is 180x. To make it a positive 180x, it'd have to be a plus sign right there. Why is the pen not working? Okay, this is aggravating. The eraser's not working, so I hope it don't mess up. Okay, so this one, possibility of it being a perfect square. So you got 7n and 4. 28n, 28n put together makes 56n. It's going to be a negative. Yep. All right, so that's perfect square trinomial. So let me just show you. I don't want you to start thinking every time the front's a perfect square and the back's a perfect square, because that's not the case. So if this thing had been a 49n squared and a 16, if it would have worked as a perfect square trinomial, it would have had to be a 7n and a 4 on the front and back, but 28 and 28 don't make 40. So it's not a perfect square trinomial. So don't just start assuming that they all are. Okay? All right, next type is factoring by grouping. Where, because remember, first rule of factoring, you always take the greatest common factor first. The greatest common factor of all 4 of those is a 1, so that's not helpful. But if you grouped it up a couple of them at a time, so out of those first 2, there's an 8r squared that they have in common, which would leave an r minus 8. Okay. Now back here, the greatest common factor is a positive 1, which leaves an r minus 8. But see, this is a product and this is a product. And so if you're looking for a greatest common factor out of those 2 things, they both have an r minus 8 in them. So if I took those r minus 8s out, it leaves me 8r squared plus 1. Okay. This one, I'm going to do the same thing. Let's say I get 24 and 64. Let's see what the greatest common factor is, just for sure. It's all 2s. So if you aren't sure what the greatest common factor is, go down to the primes. They all have, or each of them has 3 2's in it. So 2 times 2 times 2 is 8. I thought that was it, but I was going to make double sure. They both have an r squared in them. So it leaves a 3r minus 8. Now, as you can tell up here, if the r minus 8 hadn't shown up, it wouldn't have done us any good. We need a 3r minus 8 to show up. But the r here is positive, so when I get to that back 2, I'd want to take a negative and a 7, because that'll leave a positive 3r minus 8. And then this product and this product each have a factor that's 3r minus 8. And when you take that out, here's what's left. Okay. All right, so here, let's take right there 6 and an m. That leaves a 7c plus 6d. So again, if I don't get 7c plus 6d to show up, it was kind of worthless. That means I need to take a negative and an n squared back here, which will leave a 7c plus a 6d. And then that product and that product each have a 7c plus 6d as a factor. And you got that left over. Okay, so that was factoring by grouping. And we've gotten to trinomials, where that lead coefficient, which when we were talking about a, b, and c for the parabolas, it's not a 1, the a up front. Because if it's a 1, that's easy. You hunt for something that will be the back number or has to be the middle. Okay, these aren't quite as easy. There are 2 ways of going about learning how to do this. I'm going to show you one way today because I think it's the most useful way. Monday, I will show you the second way of doing it. But the second way is kind of a method where if you forget the method, you're kind of stuck and you can't do anything. So I'm not much of a fan of that because I don't want you to, a year from now, it's like, oh gosh, I don't remember what to do. Well, you will remember what to do because this is just playing with numbers until it works. Okay, this is the trial and error way. These 2 right here multiply to give you the first one. So let's just try a 5x and an x. Okay. The back, 2 numbers multiply to give you this one. So here's the thing. You could have a 1 and a 9 and a 1, or a 3 and a 3. That's all the different ways I can use integers that I can think of just to get a 9. I'm not worried about whether it's positive or negative yet. I'll figure that part out in a minute. But when you multiply binomials out, like say this, you get a 12x squared, and you're like, oh, minus 8x plus 3x minus 2. So it's like being able to combine those 2 middle terms together is the most helpful as far as trial and error goes because you can sort of see it. Like if I came up here, let's see if the eraser's working again. Oh, it's working now. So let's say I came up here to the top and put the 1 here and the 9 there. Okay, this would be a 45 and a 1 on my x's. I can't make a 12 out of that. It's not 1 and 9. Okay, if I turn it around, oops, I lost my parenthesis. Put the 9 here and the 1 there. 5 and 9, I can make a 14 or a 4. Can't make a 12. It's not 9 and 1. If I put a 3 and a 3, okay, I got a 15 and a 3. Ooh, 15 and 3, I can make a 12, either adding or subtracting. So let's make the signs work. The 3 and 3, I know they have to be different signs so that they'll multiply to be negative. 15x and 3x. If I made the 15x positive and the 3x negative, they would add up to positive 12x. So make the 15x positive and the 3x negative. And then you got it factored. Okay. So this one. 2 and an n, and then I can do a 1 and a 2 or a 2 and a 1. So let's say I'm looking at the 1 first, 2 second. 4 and 1. Ooh, that looks promising. 4 n, 1 n is 5 n. Yep, everything else worked. Okay. All right, this one, I'm just looking to see if there's a greatest common factor. Ooh, there is. Let's take that first. Let's take a 3 out. Because that just makes our factoring easier. So for the trinomial that's left, let's do a 3k and a k. And then look at this. You'll get to where you can see it. If you put this 7 times 1 to make 7, there's 21. There's 1. There's 22. Now I got it. Okay. All right. This one, you want the lead coefficient to be positive every time. So first thing I'm going to do is I'm going to take a negative out of the whole thing, which will turn it to that. Okay. All right. Let's see if we can make this work. Let's try 2a and a 3a. If that doesn't work, then we'll go with 6 and 1. What if I did a 5 and a 5? 10 and 15. Ooh, there it is right off the bat. 10 and 15 make 25. Got it. Okay. All right. And then here's some just mixed up, like whatever. We're going to factor till we can't factor anymore. So greatest common factor always first. 12 and 27. What's that going to be? A 3. X to the 5th, x cubed. X cubed's greatest common factor. It's going to leave a 4x squared minus 9. But 4x squared minus 9 is the difference of two squares. So we'll factor that down to a sum and a difference. What did I square to get 4x squared? That's the front. What did I square to get 9? That's the back. Okay. Ooh, that's it. We got it.